Hello, hello everyone. How's it going? I can see the excitement in the chat for the previous stream. Keep that up for the next stream as well. Thank you so much, Dimmer. He talked about building an emulate stream link aggregator. That was so cool. And I can already see from the comment section that it was an amazing workshop. But hold on, wait a minute. We've got more in schedule for you. There's a lot more where that came from. And there is a lot more to the schedule as well. We have a month-long hackathon running, and this is the Global Hack Week. So there's two things that you should celebrate. But today, I'm here with something really, really special for you all. As you might have seen in the Discord announcement as well. But let me give you like a little brief of what we're gonna do here. So we have an upcoming workshop with an amazing guest speaker, Savannah. She's right now backstage. I'm gonna call her up shortly. But Savannah is gonna talk to us about what on earth is Redis. I know it gets very confusing and a hackathon when you're trying to learn new technologies, but don't worry, that's what we're here for. So I'm gonna call Savannah up on stage and then ask her to take the lead on this workshop. Hello, Savannah. How you
Hi.
doing?
Good morning, good afternoon, good evening, wherever you are in the world.
Awesome. Yes, yes. We have hackers from around the world. Well, that would be a good thing to know, right? So, hackers, where are you joining in from? Pop that in the comment section, and we would love to hear from you.
Yeah, it would be great to know. That way I can appropriately say good morning, good afternoon, good evening, and good night to everyone. But yeah,
Yeah,
I'm
awesome.
excited to be here.
Wow, thank you so much for joining us, Savannah. And yes, we are excited to learn more about Redis today. I know a lot of hackers are building projects around it, so it would be great to learn more from you.
Yeah, of course.
Awesome. All right. Okay, we have folks from India. Great.
Wow, good evening. Well, yeah, if we want to go ahead and get started, if you want to throw my slides up there, we can get right into it.
Of course. Yes.
So
All right. I'll see you backstage. See ya.
okay. I'm going to leave it like this for just a second. I've got a few links up there that we're going to get into really quickly. But as Sastrika said, my name is Savannah. I work at Redis. I'm a developer advocate here. And a very quick rundown of what that means is that this is my job. I get to talk to people about Redis. I get to talk to specifically developers. I get to advocate to developers about what Redis is and how to use it and how to best use it, and maybe sometimes how not to use it and how to optimize your use cases and all of that fun stuff. But then because I work at Redis, I also get to advocate back to our core development team, and I get to tell them, hey, this is what developers aren't liking. This is what is inconsistent for them. This is what the developer experience is like right now, and this is what I would do to change that. So specifically, I am the Python developer advocate here at Redis, which means that the two demos that I'm going to show you guys a little bit about are the Python ones. There are some other ones in this that are Node.js that you can check out on GitHub yourselves, but I'm the Python person. That's my comfort zone, so I'm going to stick to that for today. So hopefully by the end of this presentation, you know what on earth Redis is, and it's a statement instead of a question. So real quick, we'll cover a recent Pokemon Go use case, a little bit about why you should care about what Redis is, some design and data type basics, and then some example use cases. So starting off strong with Pokemon Go, and Redis is a heart. We heart Pokemon Go hearts Redis. And the challenge was that those raid battles where people were joining in one specific geographic location and a ton of people were joining at one time, Niantic servers got bogged down and they needed something fast and responsive that would scale quickly to accommodate those surges, those big peaks. So to support that heightened player activity, Niantic caches a high volume of data in a Redis cluster. All of their Pokemon Go servers can access this shared data, reducing the latency and boosting performance. And this is one that I wanted to show you guys, mostly because they do a cool little breakdown here. And this is one, if you want to Google it, you are more than welcome to and read the whole article. I'm going to show a few highlights, but if you Google like optimizing Pokemon Go with Redis, you'll find this article. But as you can see from this graph, like there's a very clear, this is when the change happened. And this is when we started caching high volumes of data, where their maximum latency recorded decreased from over a second to approximately 250 milliseconds. And that's from Niantic. Also wanted to show you guys this because it leads very well into why you should care, because if we look at all of these success stories, I'll share a little bit more of some of those names, but the hint is that Redis is used at a lot of big places. So what does that mean, though, with Pokemon Go and the raid battles? Their Redis servers are created whenever a raid battle starts. So it's spontaneous. It's not just sitting there. They create a server when a raid battle starts. That user data is migrated to that new server, along with the team data, user trends, and those relationships. That way you can get into the raid battle with the people you want to be with, in the place you want to be, all of that fun stuff that makes Pokemon Go such a fun experience. I would love to know in the chat if you guys have played Pokemon Go recently. I have. I've been traveling a little bit for work, and airports are great places for Pokemon Go, apparently. But so to keep that interaction fast, the servers are created as close to the actual, that should say raid battle, not Redis battle. That's my bad. But they're close to the actual raid battle as possible. The data is stored as JSON with actions stored in queues. We've got image data, metadata, HP, CP, the user levels, and more stored temporarily. While using normal remote storage or disk storage would slow that experience down considerably from what we're at. So the next little why you should care. Like I said, I'm a developer advocate now, but I am a software developer in a previous life. And as such, I was studying for system design interviews. And actually studying for those interviews was one of the first times I heard of Redis. This system design interview by Alex Zhu. It's this book. I have it still. If you go look on that GitHub for the system design links and you do a search for Redis, I don't know if you guys can see that, but it appears in here 21 times. And yes, some of those are duplicates like this Redis geohash and then Redis in the link. But all that to say, like, there's Redis PubSub, there's Redis Geo, there's a Redis sync, there's Redis sorted set source code, there's building a real-time leaderboard with Redis, there's another leaderboards, there's why Redis clusters work the way they are, how fast is Redis. So if you're looking for a system design interview sort of cheat code, the first time I read it in that book was Alex Zhu saying, if you need to make something faster, if you need to have something in place where instead of making a round trip database time, you're going for a cache, just say you can use Redis as a cache. And while a cache is certainly not the only use case of Redis, and I'll talk a little bit more about that, it is a huge use case for Redis because it is relatively well known as a very fast database. It's in memory, but it's still safe. You can do a deep dive on that if you'd like to. There are plenty of is Redis safe even though it's in memory type of blog posts out there that you can find. But the answer is yes. And the answer is that means that it makes it an incredibly fast cache and is recommended in a lot of resources when you're doing those system design interviews, when you're prepping for those types of interviews. Redis is a great thing to have in your hat as something that you know how it works and where you can use it in your system to make it faster. So that's that one. And like I was saying with these sort of customer success stories that are out there on this page, and you can look and see like how Adobe uses the enterprise tier of Azure and sort of, they're more in-depth things. But the TLDR there is that some really big companies like Capital One, Adobe, SiriusXM, and Ulta all use Redis. And so if you want to work, at a big company, there's a decent chance that you will end up using Redis. I know some of our other success stories and some of our other customers that use enterprise Redis are also big names. There's a lot of places that use Redis, including Pokemon Go. So it's important to know a little bit about Redis because it's a fun tool. First of all, it's a fun tool to use. And second of all, it's great to pull out for interviews. So getting into it a little bit more, and this is where I'm finally going to really show some slides here. We've got the open source data structures and data types. And there's a little bit of confusion in branding around Redis open source versus Redis enterprise, and I promise it's all going to be less confusing by the end of this. But the long story short is that Redis started out as an open source project, and then people were using it so much that it needed to be scaled, and is now hosted on AWS, GCP, and Azure, and now has these sort of enterprise features like scalability, like 5 nines availability, active, conflict-free resolution data. I'm going to get that acronym wrong. But when two data types, when you write the exact same thing twice, there's some conflict resolution that happens. And we have that in the enterprise tier. That way, if you're scaling and you're using this for big things, you still get that support that you need. There's a question. I don't actually know what a TICV cluster is. So I can't answer that question, but good question. And I'm actually going to make a note of it because that's interesting. We love being challenged, especially because, like I said, I'm a developer advocate. I'm not in sales. I'm not here to sell you anything. I'm here to help you hopefully make the best choice for you and the project you're working on. So I'm going to do some digging and find out. So back to the open source data structures and data types. These are the things that you always get, that you always probably need. We've got strings, pretty common. I feel like we probably all know what strings are. It's just double quoted. Though the cool thing about Redis strings are that it does differentiate between letters and numbers. So even if it is a string, you can still use increment and increment by and decrement by. That obviously does not work with characters like letters. But Redis does differentiate between letters and numbers for those strings. Sorry. We've also got lists. There's an example in here that we'll talk about in just a second that goes into a little bit more with lists. But it's a pretty standard pop, push, left pop, right push, right pop, right pop, right push, left pop, left push, whatever combination you want to do with those things. Hashes, I'm going to skip streams for now because they're really interesting and cool. Sets, sorted sets, geospatial is latitude, longitude, and you can do some cool things there with, I want to find everything within a square radius from me. I want to make this square, and I want to know everything that matches my search within that square. Those features are also being expanded. We've got some cool stuff in the works for that. Bit fields and bit maps. And then to go back to streams real quick, because streaming data is huge. You hear about streaming services because there's so much data. And the idea is there's so much data coming in that you don't necessarily want to have to slow down to process it every single time data comes in. So in Redis, a stream collects all that data, and then you have consumers that can come and start from the bottom and start processing all of that data as quickly as they can. But there's a lot of claiming that goes on, there are consumer groups where you can divvy up tasks and have them all, do the same processing, but have multiple CPUs doing it, have multiple threads doing it, however you want to break that up. And then I also skipped hyperlog because that is actually a probabilistic data structure where there's not actually an entire guarantee about the answer you're getting. And I'll talk a little bit more about probabilistic data structures on this next slide. So in the Redis Stack data structures extension, which if you go on Docker, the main difference is going to be what Docker image you run for Redis, or when you spin up a Redis Cloud instance. Redis Stack is sort of the new, what we default to when we talk about Redis, because it has these really incredible capabilities that people want. So JSON, for instance, you get JSON, which is great. You can update specific fields, you can update a list. And when you combine that with the search that you get, you can then do something which I think I can show you. I don't have it actually as a link in here, but one of the Redis University courses does book searches. So you can look through a whole library of books and say, okay, well, I want books where their fantasy genre and they have witches somewhere in the description. And you can do that full text search over just the description field with that JSON. So those two combined become a really powerful search tool. We also have time series, which is a really handy data type if you're doing stuff over time. It makes it really convenient and easy to say, hey, give me the average from the last 3 hours, give me the average from the last 24 hours, whatever time frame you want. And then the other thing that Redis Stack added was Bloom, which is a few different data types actually rolled up into one. It's Bloom filters, it's Cuckoo filters, it's Accountman Sketch, a top K, and a T digest, which are all probabilistic data structures. The Bloom filter is, in my opinion, the easiest to explain. And it's basically a binary string, zeros and ones, where if I wanted to add something to that, I would hash my thing. We could take Savannah, for instance. If we're adding Savannah to our Bloom filter for people who work at Redis, we would hash it a certain number of times, modulo those hashes by the length of our list of zeros, and set the specific bits to ones. So now when there's a hash collision on any of those, you get into the very obvious probabilistic nature of it, where if 7 bits are set, even though you've added 4 things, there starts to be a lot of overlap and you start to get false positives. Redis actually has a feature where if you get to over 50% full, it starts to create a second layer to that Bloom filter because that false positive rate wants to stay low. But Bloom filters are used in practice with things like, there's a company whose name escapes me at the moment, but they use it to stop caching one-hit wonders. They found that almost, I want to say over 80% of the websites that they were caching were things that people only went to once. And so they were like, we're wasting so much space on caching all of this stuff that no one's going to a second time, which defeats the point of a cache. So they started using a Bloom filter to check. They add it once, and then they use a Bloom filter to say, hey, have they already been here before? And only then does it get added to a cache, because that's now a repeat visit that shows, hey, this actually should be cached. But because it's just zeros and ones, it takes up incredibly little space, and it's very quick, it's very fast. Some browsers can actually store it in the cache, so you don't even have to make any sort of cache query lookup. It's in your browser already. So that makes it a very fast way to check if something has been seen before. Redis is at its core a key value store. That's all it is. You can set a cat to mocha, set a dog to latte, then you get cat and you get mocha back. All of this is very simple, obviously, but that's the way that pretty much all of these data structures work at their heart, is you set them and you get them. So backing up just a little bit with these data types, there is a GitHub repo for Redis Labs training with MLH intro. And I just wanted to highlight a little bit of this. If you find this repo, you'll notice that this has mostly my colleague Justin Castilla's name on it. I was the one free today, but he graciously let me use most of his presentation and this GitHub repo that he has created for MLH introductions. So it's perfect for this. But credit to Justin, he did a lot of this groundwork. So Redis keys, they are binary safe. If it can be converted to binary, you can store it. It's whatever you want. We recommend sticking to a schema. And this sort of touches into the search feature of Redis, where if you want to look at users, anyone followers, you could do users : star or asterisk : followers. And then you'll search over all of the keys that match that pattern. You can do the same thing with location, products, users. We talked about it, for instance, with like rooms and university students. And if you want to reserve rooms, who should have permission to do what? And you can do all of those things by following a schema and a convention. That way, you always get exactly what you're expecting. You can give access to certain types of keys to certain people, all of that good stuff. So we recommend sticking to a schema. That way you know what you're getting. And like I mentioned, there's that anchor, which is increment Decker, which is decrement, incre by, Decker by, which just means that Redis detects the difference between strings and numbers, and you can increment numbers. You can't increment letters. The example for lists that we like to talk about is housekeeping, where new jobs are coming in from the left, and then you're popping them off the right. That way, it's a queue where it's first in, first out, as opposed to a stack. You could implement a stack instead. If you did an L pop here, you would then get last in, first out. So you could implement either one, just with the difference between the L push versus the L pop and which way you pop those things on and off of your list. These sorted sets, we'll talk about this example a little bit more later because it's a great example for leaderboards. We have all of these team scores, and when we read the sorted set back, it's already in order for us. We don't have to do any ordering. We don't have to ask for the highest score. When we ask for the sorted set back, we just get it in order. We can also get it in reverse order and see with those scores. So we can now see, and actually the interesting thing there is that the sorted set is ordered from lowest to highest. So it's sort of like golf, where low score is better. So if you want the high score, you do have to reverse that sorted set. But that's as easy as popping a REV in there for reverse. So you can see that Sue's here has the highest score. So Sue's is number 1, and it was as easy as asking for the reverse order with the scores. So going back here, you will again see that some of this is Justin Castilla and his name all over this, which props to him. He did tell me I could use this in case you were curious. I have his full permission. You can send commands to Redis via command line. You can also use something called Redis Insight, which I do have open up here, and I will show you guys a little bit more later. You can also use a Redis client library. Excuse me. So the client libraries are the things that you import into a Python file, import into a JavaScript file. It's this very first line of import Redis, import, create client from Redis, etc. And it's how, instead of having to use a command line argument, which you can still use, if you want to use a command line argument in your client library, just because some of the arguments make more sense potentially. It's not exactly a one-to-one. There are some features that are in Redis that you can access from the client or from the CLI that you can't yet access from the client libraries. That's something we're working on as a company, is that those client libraries get updated as soon as the core product gets updated. But since, as I mentioned, Redis started as an open source project, people started building these libraries before Redis did. So we now maintain them and we now control them, but we didn't always. And so Redis Pi and Node Redis don't necessarily have all of the exact features in a one-to-one way for the CLI. But you can drop into the CLI and you can just do, like, I think it's something like r.command and just send a string that is the command line command. And you can still send it that way. So you can do everything in the clients. It's just there's a couple of commands scattered throughout that don't have a perfect, pretty implementation in each different client. But you can drop into the CLI and do everything you need to do. And you can see here just some of those differences just between the Python and the Node.js. So the use case of queuing with a list. We have a head and a tail. We want to L push. So the producer puts something on the end of the list, and then the consumer, or the housekeeper in this case, takes something off the end and gets the room number and the job that they need to do. So room 101 needs cleaning. And then after that, room 309 will need a taxi. After that, room 484 will need extra towels. And then there will be nothing. And so when you pop nothing off of a list and you get nothing back, you say, great, I'm done. And this would likely be set up, if it was, scaling, if it was in a real way, there would be a consumer there checking every so often to say, okay, I need to check every 5 minutes for a new job, or every 30 seconds, or every 2 milliseconds, whatever range you want there. You set that up with your wait 2 seconds, check. Wait 2 seconds, check. As soon as there is something that gets popped off, go do whatever processing you need to do the job, check again. So very simple queuing with a list for a housekeeping example. Another use case here. Sorry, I'm starting to get a little sick, so I have to keep drinking water, some tea. So another use case here is a leaderboard with sorted sets. That's what I sort of started, or that's what I demonstrated a little bit with that Sue's example with the reverse range. But like a set, it is a collection of unique values. It is not a list where duplicates can exist. So for instance, you cannot have 2 usernames that are exactly the same, which is why this is a great case for leaderboards. Another fun thing about leaderboards is that, or usernames, I'll say, is that a lot of places use a Bloom filter to check if your username is taken, because it's so fast that instead of having to look through a set or a list, I guess with a set, sets are still very fast, but that Bloom filter is so small that it's even faster. But that's my aside about Bloom filters again. So it's not a list. There are no duplicates, which makes it a great case for usernames and scores. If you add an element that already exists, it will be ignored. And a score is associated with each element by you. You put that in. You set a Savannah has a 10 on whatever, and Sashrika has a 20, and Sashrika is winning. So all of that sorting happens automatically upon insertion. And so here is that same sorted set example with Guy, Brian, Justin, Steve, Simon, and Suze, who are all coworkers and or former coworkers of mine here at Redis. And we can use the add. We just add an element and its score to an existing or a new sorted set. So if you just say add Suze to this sorted set, the sorted set gets created automatically for you as well. And then that Z range command returns a portion of the set based on the range and those other options like the reverse and like the with or without scores options. Another use case is caching. Like I mentioned, it's a very common use case for Redis because Redis is so fast. And here's that Wikipedia definition. A cache is a hardware or software component that stores data so that future requests for that data can be served faster. The data stored in a cache might be the result of an earlier computation or a copy of data stored elsewhere. So caching a third-party API response without a cache, your application code is going to that third-party API server and it's sending it back. With using Redis as a cache, your application code is going to check whether or not you've got a cached value there. Redis says yes or no. And then the application code is going to then hit the third-party server. And then I think these should be a little bit reordered, but your application code will hit the third-party server. That third-party server will tell you the information, and then you can store that in Redis. So the next time you use it, you're not wasting API calls. A lot of APIs are limited. So you only have so many that you can use. Get this PowerPoint. That PowerPoint is in that GitHub that I will show you guys again. So yes, you can. So that third-party API server, whether it's rate limited and you only have so many requests you can make per second, whether it's just limited and you only have so many API calls per week, month, year, whatever, if it's something that's not going to change all that often, storing that data in a cache makes it quicker, easily accessible. You're not wasting your API hits, all of that good stuff. So there's the then storing it in Redis. Oh, the green is a cache hit and the red is a cache miss. It's been a little while since I ran through these slides perfectly. So that green is a cache hit, very quick, very easy. The red is a cache miss where your application code, Redis says, no, we don't have that answer. So then you go to the third-party API server. You can also cache a SQL query using Redis as a cache. Again, a cache hit, pretty much essentially the same thing here, where if on a hit, you get that SQL query very quickly. And on a miss, you're going to have to actually go through your whole SQL database do the thing, do the whole query, do whatever sorting you're getting, and then store it in your Redis cache. The caching commands are pretty much the same. It's just a get or a set. So the caching logic is you check Redis. You say, get this thing. If it exists, that's great, you're done. If it doesn't exist, you then have to fetch the data from the original source. You then return that data and create an entry using set, and that set EX adds that time to live. So that's where we get into the whether or not you want to cache something, how long you want to cache something for. One of the things about a cache is that it's usually relatively small, or at least significantly smaller than your full database will be, which means that you have to decide what's going to be in it. Part of what makes a cache fast is that it can live closer to your users, which means it's probably smaller. So that time to live will ensure that your data is fresh and updated. So for instance, I believe, yep, perfect. So this Python caching API response example is an app that I built on a live stream, actually. And I'm just going to show you the main file. It's very simple. There is an open weather key that I have locally with a base URL for an open weather map. There's a default thing, whatever. And then I have a city defaulted to Atlanta because that's where I live. So I have a try here for weather old. We're going to try to get the city name, or we're going to get the city name, and we're going to try to get the old weather. And if that weather old date time is more than 1800 seconds, how many minutes is that? 60 seconds, 3 minutes, maybe? That's wrong. However long 1800 seconds is, if the weather is older than that, we pass. We say, no, it's not good anymore. Weather changes. I don't want the old weather. So if we pass, we get to this exception where we redo the API response. You can also do this by latitude and longitude, and it does essentially the exact same thing. It's just using latitude and longitude as opposed to a city name. 30 minutes. Thank you. Yeah, so 30 minutes. And that's one of those things where you get to decide as the developer, how long do you think weather is good for? How long do you think anything else that you might want to cache is good for? Be it user data, be it stocks, be it, I'm trying to think of more volatile things. Yeah, like the stock exchange. You probably wouldn't want to cache that because it's going to change so quickly that it might not ever matter. So you have to be aware of what type of data you're using, how long it's going to be good for, and use that information to decide how long it should live in your cache, all of that good stuff. You also then get into cache expiration policies where you can decide if your cache gets full. You have to make a decision of, do you want to delete things that have been the least recently used, or do you want to do things that have been the least frequently used? So maybe something's only been touched once as opposed to something that got hit 100 times, but that one time was more recent. And it's up to you as the developer to decide what your use case is, what your data is, who's using your app, what the downfalls of each of those cases are. But all of those things play into how you define your cache policy, how long you want stuff to live there, and how you want to kick stuff out. There is also a Node.js caching example, but as I said, I am a Python person at heart and soul. So the fast weather, and that one's very easy to Google. If you Google GitHub, Savannah, Redis, weather, you'll get there. So the JSON capabilities, because JSON is so prevalent these days, and it's not hard to see why. It's very easy to read, it's very pretty, it's convenient, it's easy to access. All of those things make JSON a great data type, in my opinion, and I'm so excited that Redis added that to the capabilities where we can store lists, strings, numbers, booleans, and objects like normal JSON, which reduces the need to convert your JSON to and from strings or SQL rows. Before we had these JSON capabilities, you would have to stringify your JSON and then store it as a string, retrieve it as a string. decide if you wanted to JSONify it or not, all of that stuff. But now it's just native JSON. You can retrieve all or portions of your JSON code. So you can say, I only want these 2 fields using common commands like get and set, and it is still very fast. Can Redis be used in a React Native app for saving session data? I'm going to say probably, but React Native apps are not my wheelhouse. To touch a little bit on my background and who I am, I got a master's in computer science and then was doing cybersecurity research for a while. So building apps is actually relatively new to me. I was mostly using Python for data science, for scripting, for automating processes. So building apps is actually kind of new for me, relatively so. But I'm going to say probably. And does Redis support typing JSON objects? What do you mean? Like beyond the type JSON, like beyond, like within that JSON, are this are the fields strongly typed? Are they? I'm not 100% sure what that question means about does Redis support typing JSON objects. The type of the whole object is JSON, and then each field can be typed into, yes, fields are strongly typed. Yes, they are. So like, for instance, if you try to increment a list, it will say, I can't do that. So yes, they are. The fields under the JSON are in fact strongly typed. The search capabilities that I mentioned that combined with JSON make it super cool. The Redis Stack facilitates search of hashes and JSON, so you can search that full text, strings, tags, geospatial coordinates, and numbers. So that's when I mentioned that, like with the geospatial capabilities, you can say, I want everything within a radius of this location. I'm not sure how that circle worked on camera, but you guys know what a circle looks like, so it's okay. And you can do that full text search where you can even do some amount of fuzzy searching. There's a little bit of that in there, and there's quite a few different capabilities that you can get into with all of that search features. But text makes sense. Strings make sense. Tags are the one that I really find useful. So if you think about the library example that I'll show you on Redis University here in a minute, a genre is a perfect example for a tag, where fantasy is fantasy. You're not looking for fantastical as the genre. It's a specific word that will always be the same, which makes the indexing and the overhead a little bit faster than doing, for instance, a full text search. I am not the person who engineered all of this, so I'm not 100% sure on how all of that overhead changes between those things, but I do know that searching for a tag as an exact match, because you've specified this is a tag, it has to be an exact match, is a lot faster than doing a full text search for, I want something that has which or witchy or witches in the description. So those tags can help you narrow down your search pretty quickly. And you define what fields to search and what keys to index. So for example, you could have a field in your JSON that you don't ever want to search over, and you can reduce the overhead of that JSON by not indexing that. All previous and future keys with your defined pattern are automatically indexed, which is great for autocomplete or a very fast search feature. So the search with JSON example, I have a Python address book example, and the other thing I'm going to pop up real quick is, actually, hold on, let me pull it up over here first, is going to be one in particular course on Redis University, which, if you are not familiar, is a free learning platform from Redis. We make all of the courses in-house. These are not contracted out. This is people who work at Redis, who like Redis, who want to share the knowledge of Redis. And, oh man, let me see if I can't find this actually on GitHub, because that will make it easier to show without trying to show all of the registration steps. But all we ask for you to register for these Redis University courses is your email address. And that's partially so that if you want to get a certification, you can actually get certified on LinkedIn and have a little badge that says you are a Redis certified developer, which just means that you have taken a certain number of courses. You've done the basics. We require a basic RU101 course as well as a language specific course, but you get to choose which language. And then I think there's one other that's either required or you have to pick another course. Can I send a link? Yes, I can. Let me just find the right one because the problem is there's quite a few of them. Oh man. Apparently I am not signed in actually, so I can't send a chat, but I can connect real quick and we can do that. There we go. Oh, this comment has failed to post to Major League Hacking. I will send it to Sashrika and see if she can get it there for you guys. And it's just if you Google Redis University, you should be able to get there. But it's just university.redis.com, and it has courses that start with the basics, go through language-specific Redis, so it'll teach you the differences. Well, if you take multiples of those courses, you'll see the difference between the different client libraries. If you just take the one you're most interested in, you'll get a great head start, and you'll be able to start using those client libraries. But the search with JSON Python address book example, I'm going to walk you guys through just a little bit. So this web page, and I will send this as well. So this web page is the Redis Python Flask skeleton app, which sounds like a lot. It's not actually a skeleton app. It is actually an app that does an address book. So when we say OM, we're talking about an object mapping library, which just does a little bit more of that overhead with indexing for you. You can do all of this without the OM clients. They just sort of do some of that overhead and the indexing and that search stuff for you. But this is a great introduction to it because it does this here. Like, we'll let Redis OM handle the generation of the unique IDs. It does using ULIDs. It's great. Redis OM handles the creation of the unique Redis keys, as well as saving and retrieving those JSON documents. So it really is just an object mapping wrapping for Redis. So if we're getting started, you'll use Git, you'll clone the repository. The second most important thing in here is using Docker. You can set up a Redis Cloud instance. There is a free tier. You can do all of that. When I'm programming daily, I usually use a Docker instance of Redis just because it's easy and convenient. And it means that, right here, you'll see if you do this Docker compose up, you're up and running. If you're using enterprise, you have to have a default password and a host and a port, and you have to export your URLs. So I find Docker to be a little bit quicker to get started. But like I said, if you're doing something that actually needs that enterprise support of scaling, of 5 nines availability, of active, of all of those types of things, you really need to look at the Redis Cloud providings, where you can see how we help you handle that automatically. Some of that scaling happens, all of that. But the easy thing here is that it is a Flask application. So once you've installed those requirements, you can just export that Flask into development if you want. I'm a development environment person through and through. I don't really do much in production. So I'm always in developer mode. So once you start this running, it's not a huge UI. It's just this. And then you can load the sample data. And here you'll see where we're creating these people. And these IDs will all change because they're ULIDs. There's an incredibly low chance that you will get the same ID for the same person. So don't worry about that at all if you see that. If you have any problems, there's some debugging help in there as well. And then we can create, update, and delete and read data. So part of the thing here is doing things like the age is a positive int. So it's restricted. You cannot put a negative number in the age. And then it's a field where the index is true, which means that we can search on it. In general with Redis, if something has an index, it's searchable. But it's not necessarily full text search unless you say it is. For instance, we don't really need full text search on a positive integer, and that overhead changes, where the way things get indexed, the overhead it takes to do full text search on a specific field changes, and you want to be somewhat careful about not just being like, oh, I want full text search on everything, because then you're going to lose some of the fastness, some of that quickness, some of that, just because of all of the overhead it takes to do full text search on a field that doesn't need it. And then you can see, if you go digging in here, address is actually its own class, and it's an embedded JSON model because it has things like street name, country, unit, all of that. And then we just declare a field type of address. So address is this embedded address field. Can you add full text search to a field after it's created? Ooh, that's a great question. I'm not entirely sure. I want to say yes, because that would be handy, but I don't know the answer to that one. So I'm not gonna promise either way. But in the Redis University course that does the search stuff, it's probably addressed. I just haven't taken it in a little while. And that's a little specific just because I don't do production stuff very often. So it's not something that I come across very often. But all of that to say, it's running, it's right here. I've got all of this person data in here that has cities and street names. These are all made up. These are not real people. We've got a curl command here that is completely copy pasted from that GitHub page, where the first thing I did was the data loader, which created all these people, and then a curl for this new person with all of the JSON header data, and then I got a new ID. And then this page will also then go into examining the data, which is with Redis Insight, which I'll show you in just a second. And then these curl requests just change to be, get person by ID. There's the ID. You can do get people by name. You can do get people by age, and you can do 30 to 47. So you would get anybody back with the age between 30 and 47. All of that good jazz. You can then do some of the stuff where you can find people in a city with a specific skill. So if your person.skills contains your desired skill and their address.city is the city you want them in. So you can combine those things. You can do the things like contains. You can do all of that with all of these search capabilities. And then I am going to just do Redis University. Thought it would give me a slightly different front page than that. I'm going to sign in real quick. But actually, also right here is the would you like to know more university.redis.com. We have querying, indexing, and full text search. And these are all self-paced courses, so they do require you to enroll, and you have 6 weeks to go through them. You can extend that if you need to, but we have found that 6 weeks keeps people engaged and actually going through the courses, as opposed to what I have done as a Redis employee and never actually finished the course all the way. So you have 6 weeks to do it from the time you enroll, and that enrollment is sort of rolling. So pay attention a little bit to here, that one I can show you. So for instance, if I hit view course, you see that I started this October 27th of 2023, technically. and this course was ending on December 14th. So to earn a certificate, you must complete all of the requirements by that date. And you can just see week 1, let's see, this is Redis security. So if you're interested in, defining who can access what keys and what commands they can do on those keys, you can learn about that here. It's an access control list, but it basically says specific users have access to specific keys and can only run specific commands on them. So it's very easy to lock down your data if that's what you are trying to do. The other one that is sort of a little bit more what I talked about, if this will load a little quicker, is it's either the querying, indexing, and full text search, or the storing, querying, and indexing JSON at speed. I would recommend both of those courses when you get into those types of things with the indexing, what needs an index, what type of search can you do over specific fields, all of that. But like I said, all of this is free to you to access and go through. You can get a certification and get a LinkedIn badge if you complete all of these things. And that just shows LinkedIn that, it shows potential employers on LinkedIn that you have done the work, that you know how to develop with Redis, that you are a certified Redis developer. We also have a YouTube channel where some of these live streams happen. So like I mentioned, that fast weather app, that's very simple and very basic, but I did actually stream that. I think it's about an hour long, where I just run through getting an API key, deciding on a time frame, deciding on Atlanta, how I decided those things. And then we've also got great content and great explainer videos. So if you see this type of slide right here that has Justin Castilla's face on it and is probably 5 to 10 minutes long, it's an in-depth explanation of each of these data types. So he has a Redis JSON explained, and there's now a Redis JSON re-explained. And we have a Redis sets elaborated. So that YouTube channel is also a great place to start with sort of these more in-depth explanations. We also have a Discord. If you are programming with Redis, if you have questions, you can hop on. It's just discord.gg/Redis. I can also drop that in here, discord.gg/Redis. We do actually have an MLH tag, and we would love it if you used that. That way we can see that you learned about us through MLH. But you can also come there to ask questions, ask getting started questions. There are channels specifically, you can see them right here, for the Redis University classes. So if you're taking the Redis Streams course and you have a question, you can hop into that specific channel and you'll get responses from people that are also in the course, or you'll get responses from people who are like me, who work at Redis, who are developer advocates. Some of our engineers are in there. Our CEO actually joined the Discord, so he's in there as well. So you can see all of that. There are rules to follow. There is a welcome, here are the rules. One of them is don't just send private messages to the CEO on Discord. So all of those things, but follow the rules or we will absolutely kick you out. It is meant to be a space for learning and helping, so help us foster that environment. And other than that, thank you so much. Like I said, my name is Savannah Norum. If you have any questions, feel free to reach me at savannah.norum@redis.com. And then there are a few of those links if you want to take a screenshot or anything. We've got the university link, the Discord link, and then developer.redis.com has some other, a little more developer-specific resources as opposed to some of the marketing, some of the enterprise resources that are just on Redis.
Awesome, lovely. Thank you so much for sharing that. It was so nice to hear all of the lovely comments that are there. So I'm just gonna call out a few of those which highlight what a great session this has been. and how like everyone has enjoyed it so much. So thank you so much everyone for joining it. We do have a few minutes for a quick Q&A, so if you have any
Yeah.
questions, just post them in and we would love to answer them.
Ooh, the link for the PowerPoint. Yes, I can.
Of course. Okay, yeah, I can share that with you.
So this is the whole GitHub repository. So you will notice if you go in here, it's not exactly the exact PowerPoint. Um, these slides have Justin's name on them, and they have the Node.js links instead of the Python ones. Because like I said, this is his repository. He did graciously say, yes, I've done this presentation. You can use it as well. So this is almost the exact presentation PowerPoint, but the names are changed and a couple of those links are changed. And I added in the why you should care slide just because I think it's important to contextualize some of those people and some of those places that use Redis. But essentially that PowerPoint is in that link.
Awesome, lovely. Okay, yeah, I've shared that link in on the comments, so you can find the GitHub link there. And then yes.
Yeah, and thank y'all all so much for being a great audience and asking good questions.
Amazing, amazing. All right. Yes, we still have a few minutes. If you have any questions, feel free to post them and don't shy away. I know that there was a lot that you needed to take in with this presentation, but I really, really hope that with Savannah explaining everything, it was super easy to grasp. And if you have any questions, feel free to put them in. We're still live for a couple of minutes to help you with anything. Awesome. Thank you so much for joining in. Yeah, thank you so much. There come all sorts of comments about what a great stream this has been. So yes, I'm just going to highlight all of those as here up.
Of course. And also, if you have any questions about, like I mentioned very briefly, I went to computer science, got a master's, did cybersecurity research, and then transitioned into a role where I'm getting to speak more. If you have any questions about like career, what a master's is like, feel free to ask those because we've got a little bit of time. And I love talking to people about technology, and that's why I do what I do.
Oh, that's amazing. Like whilst people are typing in their question, I would love to ask you one. You've got so much like range of experiences. You worked as a software engineer and then you inspired to be a developer a relation. So can you tell us a little more on how this transition came into picture? How come we
Yeah.
are general at Redis and we were software engineer before?
Yeah. So right before this is when I was doing cybersecurity research at a national lab up in Tennessee, Oak Ridge National Lab. And it was a great experience and it was super cool and super interesting. And I was doing a lot of, interesting things. We were working with Navy contracts and we were doing evaluations that mattered for like cyber defense, which was really cool and fun. But I realized that one of my favorite parts of it was going and presenting and saying like, hey, here's why you should believe us. Here's why the math checks out. Here's what we did. Here's why we are trustworthy with this evaluation. And I sort of realized that if talking to people about the technology was my favorite part of my job, maybe I should find a role where I got to do that a little bit more. For cybersecurity, any platform for learning. So yes and no. There's a website called Hack the Box. I'm pretty sure that's still what it's Hack the Box. Yes, hackthebox.com. It's hacking training, which I think is really important for cybersecurity training. There are also a lot of online programs for cybersecurity that are really good. Hack the Box and Try Hack Me. Yep, those are great ones. And it helps you sort of go through that mindset of what are the vulnerabilities people are looking for. That way you say, these are the vulnerabilities I need to protect against. And that sort of white hat hacking of doing it for ethical reasons, doing it for penetration testing, doing it so that you can report it ethically. You'll notice that a really important thing in cybersecurity is going to be the ethics of it. There's a way to do all of these things in a positive way that does not expose a company's vulnerabilities to the public and cause a lot of panic. If you saw like the Las Vegas hacks where everything was shut down for weeks, like that's not good. And you can, decide how you feel about all of that. I'm not, but there's a way to do it where you say, hey, we found this vulnerability. There's even if you're doing like a master's, there's ways to ethically report things and say, hey, we are publishing this paper about this vulnerability. This is your deadline.
Mhm.
And that's still ethical. That's still, you have told the company exactly what you found. You have told them exactly when you're publishing. They have time to address it. And that's still considered ethical reporting. You can still say, through research and the appropriate channels, you can still say, hey, this is when we're going live with this. So yes, an important thing with cybersecurity is going to be the ethics of it. But yeah, Hack the Box and Try Hack Me are great resources to get started. And then online training programs, honestly, most of them are pretty similar. So I don't have any that I would really recommend over any other.
Awesome. Yeah, but I guess this answers the second question as well. How can we get started with
Yep.
cybersecurity? So the two resources recommended are Hack the Boss and Hack the Box and Try Hack Me, if
Yeah.
I get this right.
And I have not used Try Hack Me, but I've only heard good things. I've used Hack the Box, so I can speak to that one personally.
Awesome, lovely. Well, it was so inspiring to hear about your journey, and clearly, it definitely made a lot of our audience interested in cybersecurity. So I'm sure that they would have a lot of questions on that front. But for now, these are great resources that they can get started with.
Absolutely. All right. Well, thank you so much for your time. I hope everyone has a great afternoon, evening, good night, wherever you are in the world.
Awesome. Thank you so much. Thanks, Savannah, for taking time to share your thoughts with us. And yes, happy hacking, everyone. We still have a month-long contest running live. So feel free to hack away, build some great, incredible products, and use some great technologies that we have in store. Thank you so much. See ya.